Let's finish up with solving systems of equation that are given in standard form, and we're still going to work on doing algebraic solutions. So standard form, remember, is something that's given in the form ax plus by equals c. So you have your variables on the same side of the equation with some coefficient, and then your constant on the other side. So what do we need to do differently here? Well, in the last video, they were giving us things in function notation, right? So we were able to just quickly convert from function to equation, and we had things in the form that we like, which is slope-intercept form, looking like this, right? Where we had y equals, and then we had our expression. So to solve, using substitution, to solve things in this way, we need to rearrange these equations in slope-intercept form. So let's do that. So I've got 3x plus 2y equals 11. And I want to put this in slope-intercept form. So what will that look like? Well, I'll have to move 3x to the other side of the equation. I get 2y equals 11 minus 3x. And then I'll divide both sides of the equation by 2. And I get y equals 11 over 2 minus 3 over 2x. So that is my equation in slope-intercept form. And now let's do the other one. I have negative x plus y equals 3. This one's a little more straightforward. All I have to do is add x to both sides of the equation, and I get y equals x plus 3. So notice that at this point, everything is going to be the same that we were doing in the last video. We just had to take a moment to put everything in slope-intercept form. And again, the point of doing that is so that when I get to this point, I have an expression where I have y equals something and another equation y equals something, and I can think about it as saying, well, if y equals this and y equals that, then I can take this thing that is equal to y and I can plug it in right here, and that's the thing that we're calling substitution. And I will rewrite this expression, and I'm going to write it over here just for space, as 11 over 2 minus 3 over 2x is equal to x plus 3. Okay, and again from here, if I want to find the solution to this system, we can think about just doing exactly as we did before. So this will be good practice. So what can I do from here? Well, one thing I'm going to choose to do, as you know, normally we start off by doing our addition and subtraction and isolating things. But I've got some 2's in the denominator here. So what I'm actually going to choose to do is just multiply everything. I'm going to multiply both sides of my equation, every single thing, by 2. And I'm going to do this to get rid of my denominators here, get rid of my fractions so that I'm only working with whole numbers. So 11 over 2 times 2, that 2 cancels out, I get 11 minus 3 over 2 times 2, those 2's cancel out, I get 3x equals, x times 2 is 2x, 3 times 2 is 6. So the important thing there is that, remember, if you divide or multiply, you're doing it to every term in the expression. Okay, so now I can continue. Let's see, what should I do next? Let's move 3x to the other side. So I'll add 3x to both sides of my equation. I get 11 equals 5x plus 6. I will move 6 to the other side of my equation now, so I'll subtract 6 from both sides. And I get 11 minus 6 is 5 equals 5x. So x equals 1. So there's the first part of my solution, x equals 1. Now I can plug in that value of x equals 1 into one of my original equations, and you could choose to plug it in this format, this standard form, or plug it in our rearranged slope-intercept form. I'm going to choose to do slope-intercept form, but again, since all these equations that I've circled are all equivalent, it doesn't matter which one you do. I'm going to choose to plug into this guy. So I've got negative x plus y equals 3. So negative x plus y equals 3. If I plug in a value of x equals 1, I have negative 1 plus y equals 3. I'll add 1 to both sides of my equation, and I get y is equal to 4. So the solution for this system is 1, 4. Remember, this is exactly the same thing that we did in the last video. We just had to do a little bit of extra legwork at the beginning, moving from standard form and translating them into slope-intercept form. So this is also a really good opportunity for you to practice your algebra skills and isolating variables. So I really encourage you to work alongside me as I do these. In fact, if you're comfortable, maybe even pause the video before I do the work and then confirm that you and I end up at the same solution. Let's do another example. So find the solution to the system from standard form. All right, so since we're using substitution to do this, we need to get these reformatted in slope-intercept form. So if I've got 3x plus 4y equals negative 4, how can I get this in slope-intercept form? I'll subtract 3x from both sides of my equation. I get 4y equals negative 3x minus 4. Then I'll divide both sides of my equation by 4. I get y equals negative 3/4 x minus 4 divided by 4 is 1. So that's slope-intercept form. Now I have to do my other one. So I've got x plus 2y equals 2. All right, so I will subtract x from both sides. I get 2y equals negative x plus 2. I'll divide both sides of my equation by 2. I get y equals negative x over 2 plus 1. Now I'm doing this a bit quickly. Again, I really encourage you to slow down, double check this as you go. The reason I'm doing this a little bit quickly is that for most of us, this should be review at this point, but it's also a good opportunity to just continue practicing these skills whenever we can. So we have our two equations in slope-intercept form. Here's the substitution part. If y equals this and y equals that, then I can substitute this expression in right here and rewrite this as one equation with one variable. Negative 3 over 4x minus 1 is equal to negative, remember, an expression like this, negative x over 2, is the same thing as negative 1/2 x. And I'm going to choose to write it like this, just personal preference. Okay, so my goal from here is to isolate x. So I'm going to first, let's see, I'm going to add 1 to both sides of my equation. So I get negative 3/4 x equals negative 1/2 x plus 2. Now I have to deal with this fraction. Notice that one fraction for the x coefficient is in fourths, and the other fraction is a denominator of 2. So the first thing I think I'm going to do is just rewrite this. But for me, I think it makes more sense to rewrite this as negative 2 over 4. So I've rewritten it as an equivalent fraction, but I'm just matching the denominator that I'm dealing with. So I've got negative 3 over 4x equals negative 2 over 4x plus 2. Now it's easier for me to combine my like terms. Since I've got a negative 2/4 x, to move this to the other side, I'm going to add a 2/4 x to both sides of my equation. Almost out of space here. That gives me, let's see, a negative 3/4 plus 2/4 is negative 1/4 x is equal to 2. I'm going to continue this right here. So negative 1/4 x equals 2. The last thing I'm going to do is multiply both sides of my equation by negative 4. So negative 4 times a negative 1/4 is a positive 1. So that just leaves me with x equals 2 times negative 4 is negative 8. So that's the first part of my solution. Now I'm going to plug in x equals 8. Let's kind of rope all this off. So I'm going to plug in x equals 8 into one of my equations. Again, it doesn't matter if you pick one of your original equations. It doesn't matter if you look how you rearrange them in slope-intercept form and plug in one of those. In this case, I'm going to choose, again, I always just pick the one that looks the easiest to deal with. So x plus 2y equals 2 looks pretty easy to deal with. So x plus 2y equals 2. We're going to plug in our x value to get y. So I know that x is equal to negative 8. So I've got negative 8 plus 2y equals 2. And I'm going to solve this, just like I would any other algebra expression if I was dealing with variables. So I'm going to add 8 to both sides. I get 2y equals 10. And then I'll divide both sides by 2, and I get y equals 5. So the solution to this system is negative 8, 5. And I encourage you once again to double check my work, plug in x equals negative 8 into the other equation, and confirm that you get a y value of 5. Let's do one last example. So once again, we're finding the solution to a system algebraically given standard form, and we're using substitution to do it. So I've got 2x plus 5y equals negative 5, x plus 3y equals 3. I'm going to rewrite each of these equations in slope-intercept form. Okay, so I'll start with the first one. I'll subtract 2x from both sides of my equation. I get 5y equals negative 2x minus 5. I'll divide everything by 5. And I get y is equal to negative 2/5 x minus 1. All right, now for my other one, I'll subtract x from both sides. I get 3y equals negative x plus 3. I'll divide everything by 3. And I get, y equals negative 1/3 x plus 1. Okay, here's where we substitute. So we have everything in slope-intercept form. And now I've got y equals this and y equals that. So if y equals this expression and y equals that expression, then by transitive property they must be equal to each other. Or again, we call this the substitution method, where I'm taking something that's equivalent to y and I'm plugging it in for y. And I'll write it here. So we get negative 2/5 x minus 1 equals negative 1/3 x plus 1. So since this is the last example, I just want to really make it clear that that only works when we have y equals something, y equals something. You have to have the same value for substitution to work. That's why there's no way for me to do any sort of substitution with this system written as it is, and that's why I have to rewrite it in slope-intercept form. Okay, so from here, once you get to that point, we're just repeating the same thing we learned in the last video, where now we just need to isolate x and then plug in that x value into one of our equations to solve for y. So let's see, I'll add 1 to both sides of my equation. I get negative 2/5 x equals negative 1/3 x plus 2. Again, when dealing with fractions, I recommend figuring out a common denominator, which in this case is 15. So let's see, I'm looking for kind of a blank space to do this. So negative 2/5, if I wanted to rewrite this with a denominator of 15, I would multiply it by 3 over 3. So this is equivalent to negative 6 over 15x equals, and now I want to write negative 1/3 with a denominator of 15. To do that, I'll have to multiply by 5 over 5. So this is equivalent to negative 5/15 x and then plus 2. I don't have to rewrite 2 as anything, right? Because all I did was, these are equivalent numbers. I just rewrote them with new denominators so that it's easier for me to deal with them. Okay, so next step, I've got negative 6 over 15x equals negative 5 over 15x plus 2. I'm going to add 5 over 15x to both sides of my equation. Running out of room here with all these fractions. So on the left-hand side, negative 6 over 15 plus negative 6 over 15 plus 5 over 15 is negative 1 over 15 x. and that'll be equal to 2. So now all that's left is to multiply both sides of my equation. Let me get a color here. I'm going to multiply both sides of my equation by negative 15 to get rid of that denominator. So negative 1 over 15 times negative 15, that cancels out. I get, and I'll write up here, I get x equals 2 times negative 15 is negative 30. I get x equals negative 30. But once again, that's only one part of my solution. So now I need to plug in and solve. So the first example I did, the last example I did, I double-checked the answer by plugging into one of my equations in standard form, but you probably noticed that that meant that I had to do a little bit of algebra to get to the solution. So because of that, this time I'm going to plug into not this x plus 3y equals 2, I'm going to plug into its equivalent equation that I've rewritten in slope-intercept form, which is this guy, y equals negative 1/3 x plus 1. These are these are the same equations, right? I just rewrote one in a different form. One's in standard form, one's in slope-intercept. Again, I think it's just easier to deal with them in slope-intercept form when you're double checking or when you're solving for a y value. Okay, so I'm going to plug in what I know x to be, so y equals negative 1/3, x is equal to negative 30, plus 1. Simplifying, y equals negative times a negative is a positive, so I'm going to get a positive 30 divided by 3 is 10, and then plus 1. So y equals 11. So the final answer here is negative 30, 11. So that's my ordered pair. That's the solution to my system of equations written in standard form. And again, we solved it by rewriting our standard form equations in slope-intercept and then using substitution to solve for our ordered pair.